Okay, hi everybody. Welcome to the St. Louis Angular Lunch. Today we have Cory Rylan. He's going to be talking about PWAs with Angular. I try to always give my 10-second pitch. Oasis Digital sponsors this, and Oasis Digital is hiring Angular developers. That's the one thing you need to know about Oasis Digital. Take it away, Cory.
Thank you. Okay, so Cory Rylan, just a little bit background info. I'm a GDE for Angular and Web, front-end dev for a local St. Louis company, Vintage Software, and also Angular Bootcamp instructor with Oasis. You can find my stuff at coryrylan.com, and then my Twitter handle, coryrylan. So this talk is about progressive web apps and kind of how they work with Angular. So just quick vote of everyone in the group here. How many people have heard of progressive web apps? Okay, pretty much everyone. How many people have built one in a production environment, not just played with one? No one. Oh, one person. Okay, cool. One person. So I'll ask you all the questions. Okay, so progressive web app. It's one of those kind of buzzwords going around on the internet. So what is it? It's not a spec or standard of any form. So it's not like a formal web specification. There's no rules or guidelines, hard rules to say this thing is a progressive web app. Progressive web app is kind of a collection of ideas and best practices for web applications. So the term progressive web app, I believe, came out of the Chrome team. They kind of coined the term. They're the ones that are really trying to push this idea of progressive web apps. But really, it's just a good way to build web applications. So we want things to be really fast. And we're going to hit each one of these points, but we want things to be fast, snappy. Users expect the web to be just as fast as native apps, especially on mobile. When users use a mobile device, they expect it to be faster than their desktop device. Integrated. So they want things to be integrated into their operating system. So these are going to be more advanced features you see in native apps, like push notifications, offline abilities, things the web hasn't typically had in the past. Reliable, so kind of more onto the offline capabilities. So not only does the app work completely offline, say in airplane mode, but in intermediate connections. So say I jump on a train, drive through a tunnel, I would expect this app to still work. I'm not going to get the little offline dinosaur. And then engaging. So getting the user engaged in our application. So usually push notifications, background updates, things that keep our application kind of in the user's mind. So first point, PWAs are fast. So 53% of users abandon a site if it takes longer than 3 seconds. So that's a lot of revenue potentially lost if your site's running slow. And this also applies to enterprise apps. So even if your app is behind a login wall, you can take advantage of these performance characteristics. If you have a large enterprise app that thousands of developers or users in that company are using, speeding that app up by just a few seconds means those employees are being just a few seconds more efficient. Multiply that by thousands of employees, thousands of hours, you're saving your company time and money as well. PWAs are expected to be fast on limited mobile devices, so not the iPhone 10 that has a processor faster than I think my MacBook Pro at this point. It needs to work on kind of your entry-level smartphones, so the $100 Android phone or even the $50 Android phone you can just buy off the shelf at Walmart. And those devices have kind of some constraints. So there's memory constraints. You know, some of these phones only have a gig of memory at best. CPU is pretty limited on some of these devices. A lot of these Android phones you see that are maybe $100 you can buy real cheap. They'll advertise that they're a quad-core processor. Yes, they technically might be a quad-core processor, but a lot of the times manufacturer actually disables multiple cores to preserve the battery. So if you're lucky, you might get a single core, and then that core likely doesn't even have any kind of cache levels set to it. So pretty constrained on the CPU with some of the Android devices. come from the iOS, Apple world, their CPUs are pretty top-notch, so not too worried about those. And then 3G connections. So the majority of the web around the world, we're still on 3G. So we really expect these great user experiences at even 3G levels. I think most of St. Louis is kind of hitting 4G. I live about 45 minutes outside of St. Louis, so I'm pretty commonly on 3G, and you can definitely tell which sites and apps optimize for those connections. So PWAs are integrated. So I have a little demo app I built that I'll show in a few. This little kind of lunch finder app. So when I'm traveling, I just want to find some good restaurants near me, and I don't want to decide, so it just randomly picks a restaurant for me. So that's my PWA I'll show. This little screenshot here, it shows the add to home screen feature that Chrome mobile has. So the idea is with a progressive web app, we can get this kind of add to home screen feature integrated. So the way the browser determines this is if a user comes back to your web application after maybe a couple of times, Chrome will kind of notify them with this little pop-up here and say, hey, looks like you're using this kind of more often than just dropping by. Would you like to add this to your home screen? And if they hit add, Android will actually kind of package this up into a little app on your phone and add a little icon to your home screen. So to the user, this feels much more like a native app. So when they go to their home screen on the phone, your app is right there along with all the other native apps. Some kind of more interesting characteristics about this, especially on Android, is whenever this installation step happens, Android kind of optimizes that particular app, so you actually get more hardware resources than you would if you were just running in Chrome. Once you get added to the home screen, the user, if they go to their task manager, they actually see your app as a standalone app with all their other native apps. So you get a little bit more memory access, a little bit better CPU resources available. So your app will kind of speed up. And then other things users kind of expect, geolocation, camera, microphones, things that native apps have always had. So the web's starting to catch up with these things. So kind of the idea of progressive web apps is we're taking all these new features and kind of integrating them together to create these really good user experiences. So then reliability. There's a couple aspects to PWAs with reliability. There's several different techniques. We'll kind of touch a few of them when we get into the demo app. The big one you'll see if you go to like the Google developer docs about PWAs is this kind of installation app shell pattern. So this is a little screenshot I took from the Google developer docs. This pattern is kind of a UX pattern to make the app seem faster. So the idea is using some newer technologies, service workers, which we'll get into, is we can kind of get this installation step going. And whenever the user opens our app up, we can immediately render the static content. So the static content of our application is things like the header or the footer or our navigation drawer. That's not really dynamic. It's not changing very often. So if we can kind of cache that, and as soon as the user opens our app, just immediately render that, we're getting something painted to the screen really fast. So to the user, it's very much like a native app. Like if I opened up Twitter on the native, I get the UI instantly, and then maybe the tweets load in a few seconds later. So we're trying to kind of emulate that kind of native behavior. And then other aspects is we want to handle offline routing. So if I were to go completely offline and I hit a URL or hit refresh, I should not see the little Chrome offline dinosaur. I should see this app shell and some UI indication that, hey, I'm trying to get data, or be more optimistic and just show them some previously cached data. And then we'll also get into, when we get to the demo app, kind of dynamic caching. So with more advanced features, we can say, not only kind of install and cache the static assets that makes our application run, like the navigation and JavaScript, but also dynamically cache outgoing requests. So say if I have for my lunch app, I need to go fetch some restaurants from Google's Places API. I can take that dynamic request and put it in the cache. And then if I go offline, I can go and fetch that older data that I had cached previously instead of just showing nothing to the user. So last part, PWAs are engaging. This kind of just builds on a few points I've already made. Really taking advantage of some of these newer features. So things like Web Payment API, kind of a new feature making things really easy for payments checkout systems. Push notifications, which are enabled by service workers. We'll kind of see a little bit of that when we get to our Angular app. Web push, being able to kind of push content down to the device to make sure it's up to date and ready to install the latest version. And then just best practices with accessibility and UX. So these are some interesting stats I found. This is a really good website. It's called pwastats.com. It's basically this huge list of all the companies that have built a PWA in some fashion, and then their experiences. You know, what happened to our revenue, our click streams. There's some pretty interesting ones. Trivago had a 150% increase for users who added the PWA to their home screen. So getting that home screen button increases engagement significantly. Twitter Lite had kind of a new PWA launched. Had pretty good success with it. Really lightweight on my phone. Many times the Twitter Lite PWA is faster than my Android native app, depending on the scenario and which feature. But a good portion of the time, the PWA actually beats the native app. The PWA for Twitter Lite, I think, is really lightweight, like a few hundred kilobytes of storage on my device. If I go to the native one, I think it's a couple hundred megabytes. So it's significantly lighter. Going back to those users using those cheaper entry-level phones, or like the phones that you get it for free when you sign up a new contract, those phones have very limited hard drive memory. So maybe 4 or 8 gigs of memory. So having these large native apps, several hundred megabytes, that can chew away at their memory, and they're going to be less committed to keeping that app on their device. So PWAs kind of lighten that. So it's kind of like all these ideas. We want to use all these great new things, but like, where do we start? How do we know what to look for? So there's a great new tool called Lighthouse. It's kind of headed by the Chrome team at Google. Basically, it's a Chrome extension that kind of diagnoses your website or your web app. Kind of tells you, here's some things you can improve or things you can add to improve the user experience. So let me go ahead and pull up the demo app here. So this is my little PWA I built. Kind of silly. So this little PWA, hopefully the internet goes through. There we go. Okay, cool. So it uses geolocation and talks to the Google Maps API to get restaurants nearby. And then it just randomly picks one, says you should go this place. So that's my PWA, real small. So I'm going to use this PWA, and I'm going to go to the dev tools, and I'm going to use Lighthouse to kind of diagnose and inspect what I can improve on this app. So so the Lighthouse Chrome extension, you can add it as a Chrome extension. That will have the latest version of Lighthouse. That's published pretty often. The Chrome DevTools, though, actually recently added it under audits, so it's kind of like built into the browser now. This version is kind of updated whenever Chrome updates, so usually it's a little bit further behind than the extension. So if you want to see like the latest and greatest tests, use the Chrome extension. So I've got my little PWA here. I'm just going to go to the home screen, and I'm going to click Perform Audit. And I have several different options. So kind of re-emphasizing is the PWA is not one particular thing. It's kind of a culmination of different features and aspects. So you see performance, kind of progressive web appy tests, best practices, accessibility, SEO. So let's go ahead and run this. This might take a minute or two. It's kind of interesting. They show like little factoids about kind of things I mentioned with performance while you have your tests running. Okay, so once it's done running, you'll get this little kind of score sheet. So you get a score for each one of your categories. So we'll kind of run through each one of these real briefly. So performance, it will kind of give you a snapshot screen of how quickly your app renders. So this one is a really lightweight Angular app, so you get about 2.6 seconds. Now this 2.6 seconds though isn't exactly 2.6 seconds on my MacBook. Lighthouse, when it runs these tests, tries to emulate a mobile device. So it actually throttles my connection to emulate about a 3G connection. And then it also throttles my CPU to emulate a mobile device. I think it's about like 4x slowdown on my CPU. So it's trying to emulate if you were an actual mobile device. Kind of gives you how quickly were you able to get to something to the screen, and then how quickly can the user interact. So this is the other major part in performance. When we think of performance as how quickly can we get something to the screen, the other half is how quickly can the user start interacting with it. Pretty common, you go to say like a news website and you get content immediately, and then all the ads and the scripts are downloading and it's just kind of locked. You can't do anything. So it will try to give you some feedback about that. The progressive web app tests. So you can see we got 100 out of 100 with this little Angular app. And you can see there's quite a few different pieces of information here. Each one of these, if you have a failing test or even passing, it'll give you a little blurb, say why we expect this behavior, and here's a link to where you can get more resources about that. And we'll kind of hit a few of these points when we get to the demo. Accessibility. So it'll also run through different accessibility checks. So for example, your buttons are actually buttons, or if they are buttons, they have appropriate labels and color contrast. So is it really easy to read if you have a color blindness disability? Best practices. This is kind of a random grad bag of different things. So are you using HTTPS? Is it secure? Are you using HTTP2? Kind of maximize the network performance. And then SEO, depending on your app, if it's behind an account wall or not, this may not matter as much, but just general SEO best practices. Okay, so we can use Lighthouse to kind of figure out what we want to do to our app, how we can improve it. But really the big thing people think about when you say progressive web app is service workers. So service workers is this fancy new feature that's coming to all the newer browsers, and this is the mechanism that really lets your PWA shine. So it lets it work in the offline scenarios or the intermediate connections. So service worker is kind of like a proxy server in a way. So kind of this really fancy diagram here. This is my web app, as we can see. And then service worker kind of is a special JavaScript file that kind of sits in the middle here. And anytime my web app makes a request or receives a response from my server, it's going to run through this JavaScript file I've defined. And with this service worker JavaScript file, I can determine how I should handle that request. So maybe I want to cache that request because I know that resource doesn't change too often. So I can tell the service worker, hey, put that in the browser cache, and then if someone requests for it again, instead of going out to my API, just give them back the one that was in the cache. So I can optimize just cache performance. But where it really shines is if I go offline. So if the connection dies, the service worker can intercept my request for my web app. So say my web app says, oh, go get me the latest restaurants from this geo coordinate. Well, if I go offline, my service worker can say, well, we've requested that in the past. I've got a cache version. Since you're offline, let me just hand you back that. And to my JavaScript in my Angular app, it has no knowledge of this. It's kind of transparent. To my Angular app, it's just, oh, I got the request back. Let me display my list. So it's kind of this proxy right in the middle. Interesting thing about service worker is if you want that really nice add to home screen feature, you can manually do that in the Chrome menu. You can hit the little menu button, hit add to home screen. If you want to be prompted So you want Chrome to prompt the user to add it. To do that, you have to have a service worker on your website. And it doesn't matter if the service worker does anything. You can actually add a blank service worker file that doesn't do anything. And Chrome will see that as, oh, you have a service worker. You're kind of like a PWA, so I'll let Chrome, or I'll prompt the user to install you. So you actually don't have to have service worker features to get that add to home screen. With service workers, it's only enabled if you have HTTPS, so you have to have a secure connection. Just more and more of these newer web APIs require that secure connection. Just really trying to encourage best security practices. Service worker support, it's getting there, pretty close. So it's been around in Chrome and Firefox for quite a while. This was, I think I took this yesterday or the day before. So next version of Edge, service workers land. Next version of Safari, service workers land. At that point, pretty much all the major evergreen browsers will have service worker support. Now what's really nice about this feature is it's kind of a progressive enhancement onto my web app. If the browser doesn't support service workers, it just works as normal. So if it's an Angular app, it'll just work as a normal Angular app and just ignore the service worker file. So yeah, coming to Edge and Safari, so we'll have really good support across the board. Now, writing the JavaScript for service workers is not the most fun thing in the world. You get into a lot of complex behavior with caching, cache invalidation, just stuff that is not fun to program at all. So there's a couple of tools that can help generate this service worker JavaScript file. The first one here called Workbox. This is a open source project primarily ran by the Chrome team. It's kind of a generic solution to add a service worker to your web app. It's generic to pretty much any framework, so you can use it on any JavaScript framework you want, React, Angular. You can use it with just a server-side rendered website. So it's really flexible. It has quite a few more features than the Angular version. It's kind of a little bit more mature. It's been around quite a bit longer. So we get a lot more kind of out of the box with Workbox. The other mechanism, which is the one I'll show today, is the Angular Service Worker package. So the trade-offs with this one is the Angular Service Worker package is designed for Angular apps. So it's really easy to get up and running. You can get it installed and working with your Angular app fairly quick. It does have a little bit better performance than Workbox. Because the Angular Service Worker package is designed for Angular, it knows when it's appropriate to try to make requests to start caching things in the background. That way it doesn't kind of overflow the network with resources you don't need yet. It kind of hooks into the Angular lifecycle, so it knows when it's most optimal to make some certain requests. It also has some kind of more advanced features that optimize when that update process should happen. So with the service worker, we don't typically have a normal kind of refresh lifecycle. So when I go to a progressive web app and I hit refresh, if I have a service worker installed, that web app's going to start up and use whatever's in the cache defined by the service worker. It's not going to go out to my server and request a new HTML file. It's going to kind of try to stay in memory. And that's a little bit unexpected behavior when you first start developing with service workers, because you go to refresh to see changes in the browser and you don't see your changes. And it's really frustrating. You're like, what's going on? And then you realize, oh, it's running on the service worker. It's not going back to my dev server. So Angular has a couple mechanisms built in to make that a little bit easier. So to get started with Angular service workers, you can run this command ng-new, name of your project, using the Angular CLI, and then this flag service worker. And this will kind of add the boilerplate to get started. So we'll jump over to the demo real quick. And let's look at just the behavior of this particular PWA real quick. network failure. The demo gods are not happy. Hey, there we go. Okay. So we have our little lunch PWA here, and I visited the site before. So if I kind of refresh or hard land on the page, and we look at the network stream, hopefully everyone can kind of see this. You'll notice the first request here for /restaurants resource, the initiator or the size, you can see it's from service worker. So it didn't go out to my server. So this particular app has installed. So if we look at all these resources, my CSS, my JavaScript, all the things my Angular app needs, it's all coming from the service worker. So it's all in cache. So I'm not making that round trip. And then if you notice the time, very short amount of time, just milliseconds. So I can very quickly get something painted to the screen. And if I scroll down a little bit, whoops. Right here, it's probably a little hard to see if you're in the back. This request right here is my API request to go get my list of restaurants. Since I've already hit that request, we can see that one also comes from the service worker. So I'm kind of doing some dynamic caching on the fly. And we can see that particular request only took 8 milliseconds because it's coming from memory. So much, much faster than making that network round trip. Okay, so let's look at the code for this and kind of see how this works. So when you create a Angular project with the CLI with that service worker flag, you get a few different things out of the box. So real quick, the main thing is this ng-sw-config, and then our app module. Okay, so in our app module for our Angular app, we import the service worker module on line 3, and then we register it. So we can see register ng-swworker.js enabled environment production. So we only want the service worker to be running in a production environment. If we try to run this in dev mode, we get that really weird behavior of we're trying to refresh and the service worker's caching our work. So this registers our service worker. And then the CLI generates this config file. And this is where we can define the behavior of our application. When you generate this, the CLI will kind of give you some defaults. We'll see I've added a few custom things. So this first section here, index just says where's your index.html file. This is also the resource. So if you go offline or you refresh, it knows what path to go to as the default. So it doesn't 404 or timeout, so you get the offline dinosaur. Here, this assets group, this is just saying these are the things we want you to install into the cache so you can work offline. So that's going to be most of our Angular bundles, so our CSS, our JavaScript, things like that. You can also customize how these things are installed. So you, for example, I have some icons and font files here. We can define the install mode as lazy, so it means it's only going to put these in cache if I request for them. Once I request them, then it inserts into cache. These top files here, regardless if I make a request for them or not, it's going to prefetch them and put them into the cache for me. So you can more aggressively start asking for resources to put into the cache. And then where it gets really interesting is when we start doing this dynamic caching. And this is what allows my service worker to work offline. So if I go back to my demo here, and in my network, if I hit offline and everything works, because it's a demo, it should. So I'm offline completely, I refresh, and my app still works really fast too. That's partially because of this little config piece right here. So I'm telling the Angular service worker, when you generate the service worker for me, any requests to my API here, I want you to take this particular cache strategy. So there's a couple different options. There's like for performance, for freshness. So I took performance. So it's going to always go to the cache if possible first. You can define how big that cache should be. So I'm saying there should be a maximum of 50 entries. Once I've exceeded that, it'll start invalidating older entries. I can set a max age to those resources. So if it's been in the cache for longer than a day, then go ahead and go to the network and get some new information. And then I also can define timeout. So if for some reason I can't get access to that after 5 seconds, then throw a typical timeout error. So this is what allows me kind of that dynamic offline capability. Okay. The next part, try to cover real quick, is how the service worker updates. So because we have this kind of installation step, when the user refreshes the browser, they're not going back to your server and getting that latest version. They're going to be using whatever's installed onto their device, kind of like a native app. Now what the service worker will do is it occasionally will check the service worker JS file on your server for any changes. So if you go and push an update, all your users, service workers, are kind of watching that file for any updates. And if it sees an update, in the background, it's going to start downloading the latest version of your app. So it's going to start downloading the latest Angular bundles and kind of put them in memory and ready to install. Now, when the user's using your app, they're going to still be using that cached version. The service worker in the background is going to basically download those and have it ready to go. And then the moment the user refreshes, then it will load in the new version. Now there is a way to prompt the user to kind of refresh or trigger an update step. So in this demo here, I've got a, here's my app component. And on my app component, I have this little message bubble that's going to pop up. And it's got a little observable. It says, should show update prompt. So what the service worker is going to do is it's going to tell me when an update's available. And then based on that, I'm going to show the user a little prompt saying, hey, there's an update available, and then show them a little refresh button, an update button. And that will trigger them to update to the latest version of my web app. Now to do that, Angular provides a SW update service. And it exposes this available observable here. And that's just going to push me a notification. Hey, there's a new update available for the service worker. And then based on that, I'm going to show them that update prompt. Now the update process is really just a reload of the page. It's nothing too fancy. So if everything goes as planned, we can see if we can get this working. Okay, let me go back online. Okay, so what we're going to try to do is I'm going to add a console log into my app. And then I'm actually going to redeploy this. So the bundles will actually be different because the source code has changed. So the service worker will see this as, oh, there's an update to our application. And we'll see if we can get the live demo app to get our little message to show that update process. So depending on how the internet holds up, this may or may not work. So I'll let this run, and we'll see if it goes through. So while that's running, other topics don't have time to get into. Angular Universal, so this idea of server-side rendering with Angular can kind of take that progressive web app performance one step further. And then push notifications. The Angular Service Worker has a nice service built in to easily access push notifications, so you can send down notifications to the client. Okay, so let's see how this is going. It says it's updating. Yeah. Yeah. I should have skipped that. I forgot to update the command line. Is it going? Okay, it went. Okay, cool. Okay, so crossing fingers. Sometimes it takes it a minute or two depending on how quickly it's been updated on the CDN. There we go. Okay, so there's my little push or my little update. So my service worker was sitting in the background. It saw that I had pushed an update to my server. That service worker saw that, started downloading my new Angular bundles, and then just had them waiting in the background. So right now in the browser, I have both Angular apps running, both versions. I've got the one running right now on the screen, and then I have another one just kind of sitting there and waiting for me to refresh the browser. And as soon as that happens, it's going to basically shut down the old one and install the new one. So now if I hit update, it'll refresh. And if I inspect the console, there's my console log hello. So we got a successful update. And you kind of notice I was refreshing, it took a couple times, kind of that behavior with service workers is it's always defaulting to the cache. Okay, so that's pretty much my entire demo. Any questions, any points?
I have questions.
Yeah.
I'm gonna grab the microphone first. If anybody else has questions.
We need to do the questions on the mic, though.
I'll ask a couple of questions.
Yeah, there's a lot of information. I kind of just threw it
So
out
the first
there.
question is, does my Lighthouse score, is it like a measure of my worth as a human being?
What was that? Is
My
it
Lighthouse score, is that a measure of my worth as a human being?
No. Yeah, don't treat it religiously.
So related to that, like should every Angular app be a PWA and have a service worker and all that?
It depends. So a lot of the aspects of PWA, you get a lot of benefits. Say like an internal app, you may not need to worry about offline capabilities because it's on an internal network, right? But a lot of those other performance aspects that Angular can take advantage of, like lazy loading, like all those things are like PWA-ish like features. Like go ahead and take advantage of those. The offline aspect that I showed, if your app needs like the latest freshness, like I have to always show the latest data, like it's critical, then yeah, it makes no sense to use service worker for that aspect because you need that latest data.
So like are we heading to where like every site is a PWA, just some of them have it set to update right away and some have it set to update later? I'm trying to figure out what does the future look like? Should we be getting ready to PWA all the things?
I would say majority of sites are going to start moving to more PWA-like behaviors.
I'm looking for someone else to put their hand up, and I'm going to hand them this microphone. Here we go.
Just like better user experience, because there's a lot of features they threw out there, and like all those features have their pros and cons. So I see more and more sites kind of pushing towards that direction.
Well, and building on that question, do you see that being true for internal company apps, or only more for customer apps?
I see it for internal apps. A lot of these ideas, especially in the performance aspect, are somewhat challenging, and most of those challenges are because of lack of tooling. So I think as the tooling improves, it's going to be easier to take kind of more advantage of these performance characteristics. So like the Angular CLI, it's really easy to enable like lazy loading of code. And for a progressive web app, performance is really important if you want to call yourself a progressive web app. So the tooling for the CLI has improved significantly. So internal apps can take advantage of lazy loading and improve the performance of their app regardless.
I'll ask another if you don't have I'll ask another question. Okay, so I had a bunch of questions. I'm just going to hand it to anybody else to ask first, though. So I've heard of the criticism, and now I'm kind of seeing it happen before my eyes, that with single-page apps, we broke the back button. And now with PWAs, we're breaking the refresh button. Like, are we reinventing the 1990s?
I think it really depends on the behavior you want for your app. So those internal apps that need the latest freshness, it may not make sense to use a service worker to cache like all the bundle resources. So like if you need the latest, don't use a service worker for that. Now, for example, maybe that internal app, you have some endpoints to your API that are really expensive. You could leverage a service worker to just cache those like dynamic API endpoints just to kind of alleviate pressure on your server, but still not do like the offline kind of capabilities. So I can take advantage of the service worker just for certain aspects of performance and leave it out for others. And then like as for the refresh, it really depends on how you want that behavior for your users. So if you have like a customer like software as a service public facing app, that refresh behavior, you're okay with not having the latest because to the user it's significantly faster on a mobile device. And like that's worth the cost of not having the refresh button. But in that internal app where you need the latest, that cost may not be worth it. So I think there's a trade-off there you have to kind of make as a developer.
Anybody? Okay, another question.
For the service workers caching options, are there more options for the caching for different requirements?
There's quite a few options. The Angular service worker package, I think, has 3 or 4. Like there's like for freshness, so like always go to the network. The one I showed was performance, so always go to the cache. The workbox, the workbox Chrome service worker library, that one has a lot more options. You can really fine tune how things should be cached and different characteristics of how those things are cached. The couple large Angular apps that I have currently, we actually use Workbox. It just gave us more flexibility, more options to really like fine tune how those caches work. And it actually has a couple hooks into the library. You can like write your own custom cache logic. So if it's not just based off like time or size, like if there's like kind of a business rule, you can write your own custom caching.
Are there any best practices for like letting the user know that this is not the freshest data? Because sometimes I feel like it's not the freshest data, but I like on a lot of apps, I just don't know.
Yeah.
And I find it very frustrating. Like, are people trying to add in little bits of text that say, you know, updated 3 minutes ago? Like, is that kind of standard, or are we essentially trying to hide all that and just not pull back the curtain?
I'd say that kind of comes down to what your app's doing and how critical that freshness is. So for like Twitter or Facebook, if Twitter or Facebook caches some information, doesn't show you the latest, the worst case is you're missing out on your neighbor's picture of their dog, worst case. If it's a hospital and you built a PWA for the hospital, you may want to think twice about caching some information because that doctor needs the latest information about that patient. Or if you are going to cache it for maybe technical constraints, it may be best UX practices to make it obvious and tell the user that like this information was updated so many minutes ago. So it kind of depends on how critical that data is. Yeah.
Okay, so my next question is, so it looked like it was like super easy with Angular to do this, and I've actually run that command, so I know it is very easy to get the service working on an Angular app. And like with Workbox, I used to use it under its old name. It had like a different name.
Yeah.
But it was also just super easy, just like add another caching layer to like any app.
Mm-hmm.
So my question is, like, let's say I get to where most websites have a service worker. Like, is my browser going to bog down when I have 1,000 service workers registered in it?
Yeah, so there's kind of some gotchas with the service worker and memory usage. I actually ran into this fairly quickly launching my first service worker website. Service workers is limited to whatever cache resources the browser determines that site gets, and you have no control over that. Like how much cache memory you get is based on the device, based on the browser version. So you are restricted. So you have to like be very careful about what you put in there. And just like the browser cache normally, so without the service worker, you can cache resources. The browser reserves the right to evict that cache whenever it wants.
So is the service worker controlling the browser's cache, or is it another layer of additional caching?
It's the same cache that the browser has. You just have an API to talk to that cache.
Okay, so it's controlling the browser's cache. It's
Yeah,
not like
so-
making another copy.
Right, it's using the same browser cache. So you can talk to it, request, and add things to it. But the browser at like kind of a low level still reserves the right to say, I know you like asked me to hold on to that JavaScript bundle for 30 days, but I'm running out of memory, so I'm going to have to evict it. So it's very possible, and I've run into this before, to have a PWA that worked offline. It was great. I had it added to home screen, but I had not touched it for maybe several weeks. And when I went back to it, and I was actually on an airplane, I opened it up, and it actually failed. So I got the dinosaur. And it was because even though it had installed, I hadn't used it in a long time, so Chrome determined, you know what, there's more important resources for that cache. I need to take those resources and apply it to whatever sites I'm actively visiting. So it is really up to the system. The service worker is just a way to kind of tell the browser, like, this is really important, but the browser really has the final say.
What's the best practices for versioning in this? So we could be, or, I mean, if you're checking some uptime for the applications, we're hitting the URL, what version they're running, or if they're running at all, maybe it may be down, but we can still bring up the application.
Yeah.
What's the best practices around that?
So the best practices with versioning, with there's two parts. The service worker side, with the Angular service worker, it's always going to generate the same JavaScript file. And if you look at the dist real quick, so this is the generated output here. You'll see that there's a this NGS worker.js. So this is the service worker JavaScript that's generated. And then it also generates this JSON file, which basically has like hashes of all the versions for all my bundles. So it will handle that aspect of versioning. The important part, if you're going to use a service worker, is not to change this name of this file. So the way the service worker versions and knows when to update is it always goes to the same path. And then it does kind of like a byte per byte comparison. Does my current service worker JavaScript file look any different than this one? So if you rename this file, that old service worker is going to try to go looking for it and not find it. If it doesn't find it, if it gets a 404, it actually just kind of uninstalls itself. So that versioning aspect's handled automatically. The other side is kind of more for the Angular single page app aspect. And I did this on a app just launched in production. What we did is when we build our app, we actually inline a kind of like a version number hash into our JavaScript file. And then whenever like an error is thrown or we do any kind of logging, we take that version number from that particular bundle and log that. And we can actually see when we deploy, we can see like the old version, and then very slowly as the service worker sees the updates coming in, you'll like slowly see the old version go down and then the new version of that hash go up. And so like older, like traditional server-side rendered apps, like it's instant. The moment you refresh, everything's updated. With service worker, it's kind of like a slower upgrade process because that service worker takes time to install. So with that in mind, you have to kind of be careful about certain changes in your app. So like with a native app, you can't go changing API endpoints. Because if you change an API endpoint and it breaks, your native app is going to break, and it takes several days to get it through the App Store. The same thing can happen with a progressive web app. If I go and change an API endpoint, if I haven't given it enough time, users will still be on that older version, and that API endpoint is broken. So they'll actually just break outright. So that's kind of something to keep in mind, is these updates can take some time. Usually it's relatively quick, much quicker than the App Store, but it's something to keep in mind. Yeah. And then the demo for that little lunch app, that's on my GitHub. You can find it there with all the source code. So, cool.